1-2B.
Kevin, I hope you're listening.
All right, we're going to continue functions today. Still setting up our foundation for calculus, which is coming soon. All right, we're going to do 3 parts today. So the first part, we're going to learn our piecewise functions. Yeah, some of you guys did these last year, and some of you didn't. So I'm just going to treat it like it's all brand new for all of us. So piecewise functions. It's a weird name, but you do? Yeah. Basically, it's kind of like this. Like, they're actually very useful. So if you have, say, a function of time, and something isn't changing at all, it's, constant, and then all of a sudden, after 3 years go by or something, it starts to increase, okay? There's no function, well, that could be like an absolute value, but there's no function that'll do that, and then maybe from here, it starts to increase exponentially, okay? So these are pieces of a graph, but it's over a continuous domain. So you keep going to here, and then it changes to that, and then it changes here to this one. So they're all different pieces. So they're called piecewise functions. And they are piecewise functions, which means they still pass the vertical line test. Okay? Because I'll have people who will graph these. And they come in pieces, and someone will graph it, and they'll go like this, and then they'll go like that, or something. Okay? You can't do that. This might go to here, and then it goes to there, but it doesn't cross each other. You know what I'm saying? Like it might be a parabola to there, and then a line from there. You can't graph them both on the same domain. Bless you. All right, so let's do some. Number 1. Here we go. Let's start off with the basics, an easier one. Suppose that you have f of x equals... You draw a little brackety thing that you're not good at. And then you're going to graph 2x plus 1 when x is greater than 1. And negative x when x is less than or equal to 1. Okay? So first of all, if you look at this, you know you're going to have 2 lines. And it's going to be a continuous function. Well, no, not necessarily. It might not be continuous. It's going to have a domain of all real numbers, but the range might not be the same on both those parts. Okay, so here's what you should do. You should take one piece at a time. So let's deal with the first piece of this graph, okay? So go to x equals 1, right there. And our graph for this first part right here, is going to be x is greater than 1. So it's going to be to the right of 1. And what you can do is you can make a t-chart, or you can graph the whole line if you want to, and then adjust it, erase half of it or part of it till you get to 1. I like to just do a couple of points on here. Okay. Always pick this boundary point, though. X is greater than 1. You're probably like, you can't choose 1. It's x is greater than 1. Choose 1. Okay. And plug it in. And what do you get? To the first part. 3. Okay, now let's choose x is 2. I don't want to go the other way because this x is greater. Good? You get 5. Okay, so it's a line, so you really only need 2 points. And let's go ahead and plot these. Now, because x is greater than 1, we're going to put an open circle at that point. Okay, so at the point 1, 3, go ahead and draw an open circle there. Okay, and then at 2, 5, 2, 3, 4. Put a dot, and then this would be one piece of your graph. Okay? It's an open circle at 1, because you have to go all the way up to 1. And how do you represent that? By an open circle. You don't start at 1.5, because then you're missing all the numbers between 1 and 1.5. You go right up to it using an open circle. Now let's graph the other piece of the puzzle. So 2, we're going to graph f of x equals negative x when x is less than or equal to 1. So plug in 1, do 1 again, and so we get negative 1. And now let's plug in 0, because we're going to the left, and you get 0. So let's plot those numbers. So I have 1, negative 1. Thank you. 1, negative 1. And then we're going to put a solid dot there. Now it's solid because x is less than or equal to 1. There you go. And then we also get 0, 0. And so our graph would go like that. Goes through that point right there, all the way up. Okay? And that's what our graph looks like. A couple of pieces. Now, let's note a couple things about this graph. Number one, this is a function. Because nowhere on this graph do I have 2 points. No vertical line test that touches 2 points. The other thing is this is not continuous. It jumps from here to here. But the domain has a continuous domain down there. All right, pretty good. You like them? Pretty fun? Yeah.
Do we have to write the domain range?
No. Nope. Okay, number 2. You get to try one now. Yay. We'll call it g of x, just to be different. It is. Sure. Let me write this problem down. I'll let them get started, and I'll write you a pass. All right, g of x equals, let's do something a little different. Let's do x squared plus 3 when x is greater than or equal to 0. And then let's do g of x equals 3 when x is less than 0. All right, so maybe you got this, and I'm going to go ahead and start graphing this. If you want to, plot some points, feel free. This is x is greater than or equal to 0. It's a parabola that's been shifted up 3. So if you plug in, if you want to make a t-chart, go ahead. If you plug in 0, you get 3. If you plug in 1, you'll get, what, 4? It looks like a line, but we know it's a parabola. If you plug in 2, you'll get 7. You're way up here. So here's one piece. Looks like that I did. And then over here, g of x is 3 when x is less than 0. So that would be an open circle going that way. So this graph's continuous. Do you see that? It actually goes like this, and then it starts to go up. It's continuous. But there aren't 2 points here. There's only one, because this one is open circle, and that one's closed circle. Who got that? Did you get it? Good. Good. Kevin got it? Kevin got it for sure. All right, number 3.
Not you, Kevin.
Infinity.
The other Kevin.
Okay. Ooh, this one's tough. I'm going to now give you a graph, and you're going to tell me what the piecewise function is. The other way. All right, here we go. So plot a point there at 0, 2. Plot a point at 3, 0. Ooh. Plot a point at 2, 2. And then plot a point at negative 2, 0. So you should have 4 points. And then this one looks like that. Yes, they're all closed. So that's going to bring up a good point. There you go. It's a continuous function. It's a piecewise function. So there's 3 parts to this. There's 3 parts to this one. So this would be on their next quiz, which is Friday. And I would do f of x equals, and I would do that, and then you have to fill it in. Okay? So there's a graph, and you have to come up with all the different functions of it to make the whole piece. All right, so let's start. Let's do this side first, right here, this blue piece. And that is when x is less than 0. Now, you could say less than or equal to. Okay, so the answers will vary on this problem. I've decided to just make the middle part to include the 0 and the 2. So I just said x is less than 0. So now I have to come up with an equation for this. Well, that's a line, right? It's just a line. You can see what the y-intercept is. The y-intercept is 2. And what's the slope of it? Let's see. We rise 2 and we run 2.
X plus 2.
So the slope is 1. So the equation for this blue line is y equals x plus 2. And when you put it over here, you just write x plus 2 because your y is outside. The f of x is y. No, it's a positive slope. And the y-intercept is positive 2. Okay. If you can't figure it out, there's other ways. You can grab 2 points off the graph and then come up with an equation. We just did a whole lesson on that, and we took a quiz on that last week. All right, let's look at the middle part now. The middle part is just a flat horizontal line, and the equation of horizontal lines are y equals b.
2.
Y equals 2. Perfect. So this middle part would be 2, and I'm going to go ahead and say that x is less. Whoa. No. There we go. X is between 0 and 2. And I just decided to make them equal there. Okay? As long as you don't make both of these equal to 0, you're okay. Just one of them.
Can we put this in the other notation?
Yes, sure, that's fine. Interval notation. Okay, and then finally, the last piece, this piece right here. This one's a little trickier since we don't have the y-intercept. You could probably count and go over and stuff, but maybe you don't have a grid or you don't see it. I would probably pick, this is the point 2, 2, and then this is the point 3, 0. Okay, and if you have 2 points, you can find the equation, right? We just did all that last week. So you find out what m is. The slope is -2 over 1. So the slope is -2. You can put it into point slope form. Y minus 0 equals -2x minus 3. And so we get -2x plus 6. And you could have done that if you went up 2 over 1, up 2 over 1, you would have gotten there. All right, so we get -2x plus 6. And this is when x is greater than 2. Not equal to, because I already included it in my other one. And that's it. It's like 3 problems in one. So they do take a little while. All right, you feel pretty good about that one? Okay, part B then. 1/3 of the way there. There's 3 parts. That's it for that section. Yes, you're right. All right, absolute value. We've got 3 parts today, A, B, and C. Absolute value. Okay, your basic parent function for your absolute value, f of x equals the absolute value of x. You did this in Algebra 2, I think a little bit in pre-calc, Hammer-Ram. But the absolute value function is just, it's really a piecewise function if you think about it, right? It's the positive line when x is greater than 0 and a negative diagonal x is less than 0. Okay, and we're going to take that, we're going to shift it. Do you remember doing these? Sure you do. This is your mother function, and we're going to shift it. All right. Holy shift. Look at the asymptotes on that mother function. All right, what's up?
You sure you want your brother here?
Oh, my brother, he's okay with that. Number 4. Here we go. Let's go ahead and graph f of x equals the absolute value of x minus 2 plus 3. Can you do that problem without me talking to you about it? Can you do it now? I would hope so. Yeah? Because you know what? These functions, they work the same way, whether it's a parabola or a cubic function or whatever. Whatever's inside, you're going horizontal the opposite direction. Whatever's on the outside, you're going up or down the same direction. And then you know the shape of it. You know it's a V shape. If it's a parabola, it's a U shape. So we're going to take our basic parent function and we're going to shift it 2 to the right and 3 up. Did you go the wrong way? And then the number in front of x is kind of like its slope. So you would just go up 1 over 1 in each direction, and that would be your absolute value. Okay? I think that's so basic. I hope you guys can all do that. We spent a lot of time. It is basic. What is the domain and range of this graph? Domain for absolute value is all reals, all the time. The range, you have to just look at where we're starting. So, yep, we're starting at 3 and everything above that. So y is greater than or equal to 3. If you prefer interval notation, it's 3 to infinity. Either way, I'm fine either way. Any questions on absolute value? Can we move to the next thing? Real quick, if there's a negative out front, what happens to your absolute value graph? It flips down. Perfect. You guys are good. Okay. All right, last part. One more. I know, we're already at 15 minutes. Composition of functions. It's funny how sometimes you don't know the name of it, but then when you see it, you're like, oh, okay, yeah. This is what composition of functions is. Yes. F of g of x looks like fog. F of g of x, the composition of functions is functions within functions. Kind of like that one movie about the dreams inside of dreams. Inception, yes. I had to watch that a few times to figure it out. All right, F of g of x. And it's in that order. If it's F of g of x, you write it as, and people prefer this. I do too. All right, so let's do some. Number 5. Suppose that we have f of x equals x minus 7. So function f is just a simple line. And g of x is going to be our basic parabola x squared. And then when you get to these problems, there's like a, b, c, d, but they go pretty quickly. So here we go, letter A. Let's find out what f of g of 2 is. F of g of 2. Well, back in Algebra 2, when you learned this for the first time, it was confusing, right? It was like, what? I know. And now this is easy, right? Isn't that so nice? So you got it already? What do you got? -3. Yes. Okay. So start by plugging 2 into function g first, and you get g of 2 is 4. And then you're going to take that and plug it back into function f, and then you get 4 minus 7. The answer is -3. Mistakes that you made in Algebra 2 where you gave me 2 answers or you just didn't know how to do it. Yeah. 2 answers. People think it's 4 and -3. It's not. It's one string of things. I look at it like doing your laundry. You put your clothes into the washing machine first. They come out wet. You put them into the dryer, and that's your finished result.
So like 4 is the wet clothes.
Yes.
-3 is the dry clothes.
Yes. Do you do your own laundry? All right. So do my kids. All right, try this one then. Let's do g of f of 1. You try this one by yourself quietly. Let's see. Oh, yeah. Sorry. There you go. You try this one. Whisper it to your friend, your pal. You got it already? You got it? What'd you get? 36. Perfect. You know what? You don't have to show work because you're in calculus now, and this is easy. Now when we get to hard calculus, you'll have to show work. Yes, still work. Okay, what about this one? F of g of x.
Oh, that's easy.
Okay, so now.
What's the actual point you're giving us? Like, what's the?
Nothing really. Yeah.
At least you don't deny it.
I have a word problem that goes with this. It's kind of like, no? You're good? Okay.
That's okay. We don't need that.
All right, we're going to take g of x, which is x squared, and we're going to take that and replace. Okay, you don't combine them, you don't multiply them. You take this one out. It's kind of like I left to go to, I don't know, wherever, somewhere fun, and Miss Hubbard came in and subbed for me. Okay? So, yeah, I know. Wouldn't that be great? X squared minus 7.
Because Hubbard was subbing yesterday.
She didn't have one? Oh, she should have a visitor's pass. Yep, you should have called her on that. All right, alerted the office. Yep. G of f of x.
I go back instead.
All right, try this one. Try it by yourself quietly. This one's a little tougher. G of f of x. G of f of x.
Do we have to like?
Yeah, you do. Simplify it.
Oh, wait.
Oh, do you need the equations again? They're up there. The functions. So now we're taking the function f of x, which is x minus 7, and we're plugging that into g of x. So take x minus 7, plug it into there, and you get x minus 7 squared. Now, do you know how to FOIL that out without, like, rewriting it? Yeah. Take x and square it. The middle term is going to be twice negative 7x, and then plus 49. Okay? You're in calculus now. If you tell me that's x plus 49, I throw you out. I do.
That's X plus